Hello everyone, I hope you are doing well. So in this video, we are going to discuss Geeks for Geeks problem of the day, and today's problem is water the plants, and it is a medium level problem. So the problem basically says that we have been given these array of integers of size n, and like one of these denotes that this is a sprinkler and it can sprinkle water from the current position till -2 and then +2. So basically if there is a value x here, it can sprinkle water up to -x and +x. For all those positions that have a 0, they can sprinkle only on themselves because they cannot go anywhere to the left or to the right, and for the positions which have a -1, that means they have no sprinklers attached at all and they cannot sprinkle water even on themselves. Now we have to tell the minimum number of sprinklers that we have to open in order to cover all the n values or n positions, right? So for example, in this case the answer is 5. And how can we achieve this? If you open this particular sprinkler, it will cover 2 to the left and 2 to the right. So 1 and 2 will be these, and then 1 and 2 will be these. So that means by opening this center sprinkler, we can cover all of these points, right? Now this single point is remaining. So what we can do, we can just open this particular sprinkler and then it will sprinkle on itself. Now let us move on to some other sample inputs. For this particular input, the answer is -1. That means there can be no possible combination where we can cover all the plants, right? So if you try to open all the sprinklers, you will see that 4 is here. So 2 will covered on the left and 4 will be covered on the right. So 1, 2, 3, 4. These points will be covered, right? So by opening this particular 4, I can cover all of these. But now this particular sprinkler can cover itself and there will be no one to cover this particular position, right? Because it says -1, so it cannot sprinkle on itself. Now for this particular test case, the answer is 3. Let us see how it can be 3. So if I open this one, you will see that I can cover 4 on the right as well. So these all will be covered, and then these two can open or sprinkle water on themselves, right? This one will open and this one will open. So in total 3 sprinklers will open. So the answer is 3. Now let us see how we can try to solve this particular problem, and before that I am just going to take this sample test case. So we have this sample test case with us. So for each element in this particular input, what I am going to do is I am going to take this and then take this, take each and every one and determine the positions they can sprinkle water in. So let me just write those positions first. So let me just write the indexes. So this position 0 sprinkler, there is no sprinkler at all. So let's say it cannot spray water at all. So I'm just going to give it a very huge value, right? So I have given it a huge value which is infinity, which is beyond the scope of this particular input, right? Now for index 1, what I can try to do is, it is at index 1, it can go up to -2. So that means it can go up to -1 and then 1 plus 2 is 3, right? So this is the range in which this particular sprinkler at index 1 can go. The second sprinkler can go up to 0 and then it can go up to 4, right? The third sprinkler, again it is -1, so I initialize it with infinity, right? Now for the fourth sprinkler, it can only go from position 4 to position 4. For the fifth sprinkler, it can go to position 5 to position 5, right? Now if I sort all of these values with respect to the starting position, so what I'll get is, I'll get -1, 3, then I'll get 0, 4, and then I'll get, let's say, 4, 4, and then finally I'll get 5, 5, right? So now what I have done is, I have arranged the sprinklers in accordance to their starting point. I can even ignore these particular sprinklers which have infinity value because they don't matter at all, and their values are lying outside the size of the array, which is roughly 10 raised to power 5, right? So we need to focus on these 4 sprinklers which have the starting and the ending range within our constraints. Now what I can try to do is, I know that the next sprinkler that I want to take, or the next position I want to take, is 0, right? So let's say I initialize a variable take and I say that I want to currently take 0 because I have not covered position 0 yet, right? I have covered all the positions before it, right? Let's say I'm just talking about position -1. Let's say I am saying that I have covered position -1, the first position I want to cover is 0, right? So now what I do is, if the starting sprinkler, since they are always arranged in increasing order of this particular starting point, if this particular value does not cover this particular take, then none of the values after it will cover this particular take. So for example, let's say instead of -1 here, there was some value, let's say 6, right? So all the values after it are going to be 6 or then greater than equal to 6, 7, 7, 8, 10. So if this first value does not cover this particular take, then none of the values after it is going to cover this particular take. This is my first fact, right? So now what I am going to try to do is, I am going to check whether this particular point is able to cover this particular take or not, right? So I want to take 0, but I also want to take a sprinkler such that I can cover maximum number of sprinklers in terms of this length, right? So what I can try to do is, let's say I start from this particular index, I see that -1 is less than equals to this particular take value. So that means I can definitely use this sprinkler to cover this particular point that I want to cover. Now I move on to the next index just to check whether this particular point can cover this take as well or not, right? So I see, yes, this can also cover this particular take value. So basically what I am saying is, in this take variable, I have a value which I want to take next, right? And I am looking for that particular value inside these first coordinates, right? So what do these ranges signify? They signify that this particular sprinkler can cover this range. So if my take lies inside this particular range, that means I can definitely try to use this particular sprinkler to cover this particular point take, right? And again, I cannot choose any one of the sprinklers. I would want to choose them in such a way such that I can take the maximum number of positions at once, right? So now what I have done is, let me just come back here. I have realized that these 2 points are both valid points because they are going to cover this particular position take, right? This is starting from -1 and this is starting from 0, and both of them are going to cover this take, right? Now what I have to do is, I have to look at their second coordinates, right? And again, before coming on to this part, I cannot use this particular value because it is 4 here and this will not cover this take position that I want to take, right? So the only two valid options are these ones. So among these, I have positions 3 and 4. That means this first sprinkler is only going to cover up to position 3 and this second sprinkler is only going to cover up to position 4. So as I said, I want to maximize the positions that I cover, so I will take the maximum of them, right? So among 3 and 4, the maximum is 4. So that means if I take this particular sprinkler, I would be able to satisfy this particular condition and I will be able to cover all the positions till index 4. Once I know that I am going to take the sprinkler, I have to do two things. First of all, I have to increment my answer, and the second thing is what I have to do is, I have to update my take. Now since I have covered all the positions up to positions 4, up to index 4, my take is going to be 4 plus 1, and that is 5. That means this 5 is the next element or the next position that I want to take. Now since I have a 5 here, I know that the next position that I want to cover is 5. So I come on to the next index, that is this one. I check whether this position will be able to cover 5 or not. Yes, definitely this is 4, that means this particular sprinkler will start from position 4, right? Similarly, this particular so the next one, this next sprinkler will also be able to cover this position 5, but again I have to take the maximum among them. So if you see, this is 4, this is 5, the maximum among them is 5, right? Now I have to check whether this position is able to cover this one or not. Only if it is able to cover this one, then only I am going to take it, right? And at any moment of time, if I realize that any sprinkler is not able to cover my positions, then I can return -1 at that particular moment only, right? So all you have to do was, so let me just write the approach here. We'll write the final approach, right? So try to take sprinkler ranges greedily, right? check if there are any ranges which can satisfy the next position that I want to take, right. If no position exists, then return -1, otherwise take the position that covers maximum number of positions, right. Otherwise take the sprinkler actually, or if no sprinkler exists, right. So this is what we are trying to do. We are just trying to take the sprinklers greedily and check if there are any ranges or sprinklers that satisfy the next position that I want to take, right. If there are no such sprinklers, I just have to return -1. Otherwise, when there are multiple such sprinklers, I'll have to take the one with the maximum ending position, right. So this is exactly what we will try to do, and now let us have a look at the code. So what I have done is I have initialized a vector of pairs called cover. So this is basically going to denote the ranges that my sprinklers are going to cover. So if gallery of I is equals to -1, I just initialize both of them with minus 10 is power 7. Otherwise, I initialize it with I minus gallery of I, comma I plus gallery of I. So this is the minimum position and this is the maximum position. Now I just sort the whole cover vector according to the minimum position. I have initialized three variables: take, index and answer. Now take is going to denote the next position that I want to take. My index is going to denote the current index in this cover vector, and my answer is going to denote my final answer. So while take is less than n. So why this condition? Because when take becomes equal to n, that means I have taken all the positions from 0 to n minus 1, right? And that means I have satisfied my criteria of taking all the positions. So my while loop should only continue while take is less than n. Now I initialize my nax with take -1, right. So this nax is basically going to denote what are the positions that I have been successfully able to take, right. So what is take? Take is the next position that I want to take. Nax is going to store all the positions that I have successfully taken till now. So if 0 is the next position I want to take, that means -1 will be the position that I have successfully already taken, right. That is why I initialize my nax with take -1. Now I maintain a while loop while index is less than n and cover of index dot first is less than equal to take, right. That means this particular index is able to cover this starting point, right. This is what I want to mean by this particular condition. Now if this is true, I update my nax as maximum of nax comma cover of index dot second, and I also increment the index with the help of post increment operator. So once this equation is executed, the index will automatically get updated. Now if nax plus 1, what is nax plus 1 now? So nax is the positions that I have been successfully able to take. If I add +1 to it, so this will be the next position that I would want to take. So if there was an update in the take variable, that means I was successfully able to take one of the sprinklers which satisfied all of my conditions, right. If this is not true, that means I was not able to take any sprinklers and I just have to return -1. So this is true, I increment my answer and update my take as nax plus 1, right. And after all of this has been done, at the end I can just return my answer. So let me quickly submit this and show you that this particular solution works and this code is absolutely correct. So it's taking some time, I guess. Yep, it passes all the test cases and this solution is correct. I hope that you guys were able to understand the solution. If you guys did, then consider dropping a like on this video and don't forget to share thoughts in the comments, because your engagement with this video really helps YouTube algorithm to understand that this video is actually helpful for you and it will be able to reach much more people like you who want to keep solving new problems. So that is it for today. Till the next video drops, keep coding, stay safe, bye bye.